Welcome to the Security Village, a creative way to understand key security models. Bell-LaPadula (BLP) first meet the gatekeeper. Bell-LaPadula keeps secret locked away. Think of someone guarding the castle gates, making sure no one leaks confidential info. Biba model. Next is the cleaner. Biba ensures everything stays clean and trustworthy, like a chef who never lets spoiled food mix with fresh food. That's integrity. Clark Wilson model. Here's the shopkeeper. Clark Wilson runs a secure store where every transaction is checked. No one can mess with the cash register without following rules. Brewer-Nash or a Chinese wall. Then we have the wall builder. Brewer-Nash builds wall between rival companies so secret don't mix, like a lawyer who never works for two competing clients at the same time. Graham Denning model. Graham Denning decides who gets keys to which room and controls who can create, delete, or transfer objects in the castle. Harrison-Ruzzo model. Finally, the rule maker. Harrison-Ruzzo writes rule for changing permissions like a judge who decides when someone can gain or lose access. These six models form the backbone of access control, easy to remember when you picture them as characters in the security village. Let's break down the Bell-LaPadula model, a cornerstone of mandatory access control. Picture a castle with a gatekeeper holding a shield and a lock, symbolizing strong access control. This model focuses on confidentiality and enforces two key rules. Rule 1. Simple security property. Simple security property, no read up. This means if you are at a lower clearance level, you cannot read data from higher level. Think of it as you can't peek into castle's top secret tower. Rule 2. Star property. Star property, no write down. This means if you are at a higher clearance level, you cannot write information to a lower level. Why? To prevent leaking sensitive data outside the castle walls. So Bell-LaPadula, no read up, no write down. It's all about protecting confidentiality in the hierarchy system. Let's make Bell-LaPadula easy to understand with a real-life analogy. Imagine you are an employee standing outside a VIP room labeled top secret. You are not on the VIP list, so you cannot enter the room. This represents no read up. You can't access information above your clearance level. No write down. Now picture someone inside a VIP room with top secret folder. This means if you are at a higher level, you cannot share secrets with low level. That's no write down. So think of it like a VIP party. If you are not on the list, you cannot enter. No read up. If you are inside, you can't leak secrets outside. No write down. That's Bell-LaPadula in action. Now, let's look at the Biba model, which focuses on integrity. Imagine a cleaner with mop symbolizing keeping things clean and trustworthy. The goal here is simple: maintain integrity. Rule 1. Simple integrity property. One rule says can't read down. This means you cannot read data from lower integrity level because the data might be dirty or unverified. Rule 2. Star integrity property. Star integrity property can't write up. This means you cannot write data to higher integrity level to avoid contaminating clean data. Easy way to remember: can't read down, can't write up. The Biba model is widely used in financial systems where data integrity is critical. So while Bell-LaPadula protects confidentiality, Biba ensures integrity by keeping the data clean and trustworthy. Let's make Biba model easy to understand using a food safety analogy. No read down. Imagine you are a chef in a restaurant. You have a fresh, clean ingredients on the counter. That's high integrity. Next to you is a trash bin with spoiled food. That's low integrity. You cannot take food from trash and cook it. This represents no read down. Don't read from dirty sources. No write up. Now, if you're working in the kitchen, you cannot serve unfinished dishes to VIP dining table. This represents no write up. Don't write to clean places unless you are authorized. Think of it like a food safety. Don't read from dirty sources, trash, Don't write to clean places, VIP table. That's the Biba model in action, maintaining integrity. Now let's look at a Clark-Wilson model, which focuses on integrity through well-formed transaction. Remember, well-formed transactions. Picture a secure store where every transaction is verified. There are trusted items that must stay accurate and unverified inputs that needs checking. To keep everything safe, all changes go through a control process. At the center is the cash register representing transformation procedures (TPs). This ensures that updates happen through authorized, well-formed transactions. So the Clark-Wilson model guarantees integrity by requiring all updates to follow strict rules. It's widely used in commercial systems like banking where transaction accuracy is critical. Brewer-Nash model, also called Chinese wall model, aims to prevent conflict of interest. Remember, aims to prevent conflicts of interest. It uses dynamic access control based on previous actions. If you access one client's sensitive data, you are blocked from accessing a competitor's data to maintain confidentiality. This model is widely used in consulting firms and financial institutions. Graham-Denning model goal is secure object creation or deletion and right assessment. It focuses on access control operation. Think of a castle. The key master decides who get keys to which room. They control who can create new rooms or objects, delete them, or transfer ownership. In system, that means only authorized subject can perform a safe operation on objects, protecting integrity and ensure proper rights are set and changed. Graham Dining clear rules for who can do what to which objects and under what conditions. Let's take example. Graham dining model like hotel analogy. Imagine you are in a luxury hotel with the VIP suites. Each suite represents an object in the system. Guests are subject who need access. At the front desk stands the key master. The key master decides who get keys to which room, who can create new suites, who can delete old suites, and who can transfer rights to other. This is exactly what Graham Denny model does in cybersecurity. It defines secure operations for creating, deleting, and assigning rights to objects. Why it is important? CISSP questions often ask which model focuses on access control operation, which model ensures safe object management. The answer is Graham Denning model. Think of a key master in a hotel controlling every key and every room. Harrison-Ruzzo model. In the village of superheroes, security is managed by control tower. On the big board, the access matrix, each superhero has a specific power and permissions. Over time, this rights changes. New powers are added, old powers are removed. The chief strategist ensures every change follows strict rules to keep the village secure. This is exactly what Harrison-Ruzzo model does in cybersecurity. It formalizes access rights and how they change over time using access control metrics. CISSP questions often ask which model focuses on the rights changing over time, which model uses access control metrics. The answer is HRU model. Think of the chief strategist updating the superhero board, secure, controlled, and rule based. Just to avoid confusion, let's have a comparison table. So Graham Denning, Harrison-Ruzzo. Goal is secure object creation and deletion and right assignment. Harrison-Ruzzo formalizes access rights and change over time. It focuses on access control operation. Harrison-Ruzzo focuses on access control matrix. Key concept: define safe operations on subjects and objects. Example: create, delete, transfer. Use a matrix to represent permissions and the rules for adding, removing rights. CISP question hint: which model focuses on secure operation for objects and rights? Harrison-Ruzzo: which models focuses on rights changing over time using matrix? Primary use: Graham Denning, administrative control of object lifecycle. Harrison-Ruzzo, formal verification of dynamic right changes. Let's summarize. Bell-LaPadula for confidentiality, Biba for integrity, Clark-Wilson for well-formed transactions, Brewer-Nash for preventing conflicts of interest, Graham Denning for secure object operations, and Harrison-Ruzzo for managing rights over time. These models aren't just theory. They form the foundation of access control and data protection in the real world system. Remember, CISP questions often test which model applies to which principle. Use these analogies we discussed, like the hotel key masters and the village of superheroes. Mastering this model means mastering the logic behind secure system design. Thank you for watching. Stay tuned for more CISP simplified content.